Hello folks, you're welcome once again to another series in plane geometry. In the first series of this plane geometry, we considered definition of terms. Firstly, we looked at the definition of geometry. And in that series, we said geometry is the study of the properties of shapes. And we went further to say that these properties can manifest themselves in the form of a definition, in the form of theorem, axiom, in the form of lemma, corollary, and so on. And we also gave a definition on each of these terms. Like, for example, we gave a definition of an axiom, of a theorem, and so on like that. And also the basic knowledge that is required to grapple through with plane geometry are also highlighted in that series. So I would strongly advise that you go over that series once, twice, and thrice to get a proper grasp, because that series will serve as a foundation to subsequent work. That series also serves as a foundation to what we are doing now. So if you don't have a proper grasp of that particular video, you may not be able to grapple through with this particular series and subsequent video we shall be creating. So I strongly advise that you watch that particular video, pay close attention, make sure you get all the detailed explanation, then you can come over and also the same thing with subsequent work we shall be considering in plane geometry. And as an addendum, I will like to inform you that I render a personal online math tutoring service, even the group online math tutoring service. So if you're interested in this service, be very free to get across to me. Not only that, I assist in providing solutions to assignments and tests, projects, and research work. So if you are in need of any of these services I've mentioned, be very free to get across to me. Alright, also do me the favor to like, share, comment, and follow the page for more exclusive mathematics video. I'm a mathematician. I study mathematics to the university level, and I've been involved in teaching mathematics to various class of students, primary student, pupils, secondary or high school, and even to the undergraduate level. I've been involved in tutoring mathematics. So I'm a prolific mathematician. Alright, so be very free to get across to me if you're in need of these services. So let us continue with our study on geometry. Now this time around, we are looking at a particular figure called triangle. What is a triangle? Definition. Over here we said a triangle is a closed plane shape that is bounded by three straight line segments. So a triangle is a closed plane shape that is bounded by three straight line segments. Alright, so what you should notice is that a triangle is a closed plane shape. It's a plane shape, alright, and it is bounded by three straight line segments. Now I want to look at some terminologies about the triangle. Now that takes us to the next subheading: interior and exterior of a triangle. The interior and the exterior of a triangle. What is the meaning of interior of a triangle? Take note, I didn't say interior angle. Rather, I said interior of a triangle. Also, I consider the concepts of exterior of a triangle. Now, let's look at the first. The region bounded by the three straight line segments of the triangle is called the interior of the triangle. So, in this case, interior is a region. Alright, when we say the interior of a triangle, we mean a region, and that region is bounded by the three straight line segments of the triangle. So any region that is captured by these three straight line segments of a triangle, that region, the name of that region is called interior of the triangle. Alright, interior of the triangle. Now, if you observe carefully, angles within this interior, whose sides are any two sides of the triangle, are called interior angles. Alright, so there's one thing for a triangle to have interior, and there's another thing for a triangle to have interior angles. Interior angles are simply the angles within the interior, whose sides are any two sides of the triangle. You know, in the passing video, in the first series, where you were taught the sides of an angle. Angle has side, the first side and the second side. Alright, but this time around, the interior angles are the angles whose sides are any two sides of the given triangle. So that we call those kind of angles interior angles, because they are within the interior of the triangle. Now the next we are looking at is the concept of exterior of a triangle. Now over here we say the region not bounded, all right? That is the criteria. The region not bounded by the straight line segments is called the exterior of the triangle. All right. So if a line segment is extended into the exterior of the triangle, a non-interior angle will be formed called the exterior angle. Look at this I've said here is illustrated below. You see this dark circle? The white region represents the interior of triangle ABC. All right. While the angles ABC in green. All right. Can you see that? The angles in green. Let me illustrate with this symbol. Can you see this? This you see here. Then also this. Then lastly you see this. All right. So these angles are called the interior angles because they are within the interior of the triangle. That is, they are in the white region. So they are called interior angles. Now, if you observe carefully, the line segment AC, that is this line you see here, AC, can you see that? This line was produced, in other words, it was extended to the point D, all right? And by so doing, we have an angle that is not within the interior, this angle here. Can you see this angle here? This angle is called the exterior angle. Now, the entire dark region around the triangle and furthermore, further away from this dark region is called the exterior of the triangle. So please distinguish carefully between an interior of a triangle and exterior, and also the interior angles and the exterior angles. All right. The exterior angle in this case is obtained by an extension of a side, a line segment of the triangle. When an extension is made on any side of a triangle whatsoever, there must be an exterior angle. All right. So that is it. Now we want to look at the first theorem so far. Now this will be our first theorem. Now we said in the first series of this geometrical video that a theorem is an implication, and an implication has two components. The first component is the antecedent, or you call it hypothesis, while the second component is the conclusion or the consequence. All right. So the hypothesis is the part that is to be assumed to be correct. All right. It's the given part. Is the part that is given to be correct, is to be assumed. And on that assumption, we are required to establish that the conclusion is valid. So that is a theorem. So a theorem is an implication. Now look at the first theorem here. It's about the triangle. Now what is the theorem talking about in this place? You say if ABC is a triangle, then the sum of the interior angles is two right angles. All right. If ABC is a triangle, then the sum of the interior angles is two right angles. So in this case, the hypothesis is if ABC is a triangle. And in effect, what is given to us in this theorem is that ABC is a triangle. That is what is given to us, right? Then the conclusion here is that I said then the sum of the interior angles is two right angles. That is the conclusion, or you call it the consequence. Now this theorem given in implication form can be also rendered in ordinary form as follows. Instead of seeing it in the if and then format, you may see it in this other way. In some mathematical literature, you will see it as the sum of the interior angles in a triangle is two right angles. So we all say it like that. All right, it's the same thing. This form is called the ordinary form. Why the first form I gave here is the implication, form. All right. So in this case, we shall be using the implication form because it's clearly defined what is given to us in the problem. Now, don't forget, in the first series of the video, I also said that when carried out the proof of geometrical theorems, we are required to work according to the geometrical tradition or custom. It is customary to carry out the proof of geometrical theorem as follows. The first step is that there should be a statement of the theorem. In this case, it has been given to us by default, and the statement here is if triangle ABC is a triangle, then the sum of the interior angles is two right angles, or you can put it in the ordinary form as the sum of the interior angles in a triangle is two right angles. So this is a statement of the theorem. All right. Now the second step in the tradition is that there should be a diagram of the figure under discussion. Now, in this theorem, what is the figure under discussion? You agree with me that they are talking about a triangle. There should be a diagram of it. And when we say a triangle, we know the article A is an indefinite article, and that means that we are talking about a general triangle here, not a specific triangle. So when we are drawing the figure, as in this case, when we are drawing the figure, this figure is a representative of all triangles. There are infinitely many triangles, all right? So we have to prove that the sum of the interior angles in those triangles is 2 right angles. So we have to prove it. So this triangle you see here is not a specific triangle, but it's a representative of the infinitely many triangles we have. So having drawn the figure that is discussed in the theorem, we go over to the next step. What is the next step? Giving. What is given to you? Now, what is given to you is captured in the antecedents of the theorem, or you call it hypothesis. Now, if you come over here, you will see that the theorem states that if triangle ABC is a triangle, that means we are given that triangle ABC is a triangle. That is what is given to you, all right? Always put what is given to you in mind, because you use that and other addition if necessary to establish the conclusion. Because sometimes what is given is not sufficient to establish a conclusion. You need an additional property which is based on your previous knowledge to be added to what is given to establish the conclusion. All right. Now, in this case, we are given that triangle ABC is a triangle. That's what is given to us. So we report it in the given row. So over here, the report here, we say any. Let me use a black. We can say any triangle ABC. All right. By the use of the word any, we mean the triangle ABC in this diagram is a representative triangle. Now, having done that, we should give a statement of what is to be proved by simple lettering. So let me call this angle here. Let me call this alpha. Let me call this beta. Then let me call this lambda, right? So what are we to prove? What is to be proved is in the conclusion of the theorem. It says if triangle ABC is a triangle, then the sum, that is the conclusion or the claim, then the sum of the interior angles is 2 right angles. So in other words, we have to prove that the interior angle, the sum of the interior angle, which is alpha plus beta plus lambda, is equal to 180 degrees, as 2 right angles equals 180 degrees. All right. Now, what is given to us in this given line? I mean here. I mean this row. You see this row? What is given to us here may not be sufficient to carry out the proof of the conclusion. You know, this is the conclusion, all right? So we want to establish that this conclusion is true. Now, what is given to us is not sufficient to carry out the proof. Now, we have to add something to what is given, all right? Now, how do we add an information to what is given? We do that by previous knowledge. You must know something in passing in order for you to add to what is given, so that you can establish a particular conclusion. All right. Now, what do we know in passing that is also 180 degrees? That is, what do we know in previous video, in the first series I created, whose sum is also 2 right angles? If you follow through that series, you will discover over there I said that the sum of adjacent angles on a straight line is 180. So that fact is about sum also, and it's about angle, and the sum is 180. So that fact in a way resembles this fact, but in this case we are dealing with sum of interior angles. So there may be some relation between that fact, which is an axiom in the first series of this video, and this particular theorem we are trying to prove now. This relationship, the only difference is that one is talking about adjacent angles, the sum of adjacent angles on a straight line, all right, equals 180. But this one is talking about the sum of interior angles in a triangle, being 180 degrees. So how do we connect this? How do we bring them into consensus? How do we do that? To do that, we shall make possible extension. You know, that fact, not angles, all right? And I've explained what is meant by adjacent angles in the first series of this video. So if it is difficult for you to grapple through with this particular video, I strongly advise you to pause for the now, go and look for the first series, watch it, spend time with it, then come over to this one, because that is a foundation to subsequent videos. All right. Now, look at this construction. What do we construct into this scenario? This is what we do. We shall proceed. We shall proceed and produce rather any side of the triangle to have adjacent angles. We can produce side AB or side AC or side BC. Anyone you want to do is okay. All right. So I will take side AB. Let me extend side AB. So if I do that, let me take this pen. All right. If I do that, I shall be having this. Look at this. I shall have this. So I will call this point D. All right. So if you observe carefully, this angle here now is now an exterior angle because it's in the exterior of the triangle. All right. That is angle DBC. Or you can call it angle CBD. Because in the first series of the video, I just have to name angle. When naming angle, ensure that the vertex is at the middle of your order of naming. Otherwise, you will be naming a different angle. All right. So please take note of that. Now, you see that this angle CDB, let me call it phi, for example. Let me call it phi. This is phi. All right. So let me label it as phi. So angle CBD is an exterior angle. Why angle CBA, that is lambda, is an interior angle of a triangle. Now, if we use the fact that the sum of they are adjacent, in the sense that they are next to each other and they have the same vertex, so they are adjacent angles and they are in a straight line. So their sum is 180 degrees, but there is a problem. What we shall do now, we shall try to bring this alpha and beta to be in this exterior angle. How do we do that? How do we possibly bring alpha and beta so that they are part of the exterior angle phi, that is part of the CBD? In order to do that, there's something you know I taught you in the first series. Over there I said that alternate angles are equal if the lines that form them are parallel. All right. You know, in that video I said it is one thing for angles to be alternate. It is another thing for them to be equal. All right. It is one thing for angles to be corresponding, and it's another thing for them to be equal. So the fact that angles are corresponding does not mean they are equal. All right. So please take note of that. For corresponding angles to be equal, the lines that form them must be parallel. Now, if you observe carefully, to make this alpha and beta to come into this external angle phi, we shall make the following construction. Let me take my meter rule now. Here's this meter rule once again. Okay, look at it here. So in this case, I shall draw a line through B. Now, there are infinitely many ways of drawing a line through B. So many. But we shall take the scenario whereby the line is parallel to the side AC. Why are we choosing parallel? Because we want a situation whereby corresponding angles will be equal and alternate angles will be equal. In that way, we shall be able to bring alpha and beta, which are the interior angles of the triangle, into parts of the exterior angle if we do that, right? So from this point B, we shall draw a line as follows. Look at the line now. We shall draw a line in this manner. Can you see that? Then let me remove this. So let's call this point A. So this line we draw is parallel to this side. That is intention. Can you see that? So we've done that already. So we report what we've done in this line. We report it. You see, you add it. Now this was not given to us. We added this to what is given. We are giving a new triangle. We are now adding this fact to it because of previous knowledge. You see how previous knowledge enables you to construct profitably. So to know what to construct, you need previous knowledge. All right. Also, it's not only in geometry. In real analysis, we don't construct, rather we define functions. Now, if they give you a certain antecedent and that antecedent is not necessary to establish the conclusion, you can define a function in addition to that antecedent so that you're able to prove the consequence. And for you to be able to define a function profitably, you must have a prior knowledge of some facts that will enable you to define a suitable function. All right, that will enable you to prove a particular theorem in analysis. Now, we report what we did here. Let's report it. We can say, draw line AB produced at D. All right, you see that? And draw line BC line BC to be parallel to line AC. Can you see that? All right. So we've reported what we added to what is given to us. Having done that, we go to the proof. Now the proof should be in the form of a reasoned argument. It should be in the form of a reasoned argument. So let's begin to reason. Now take note of this, that since line AC and line BC are not parallel by construction, we have that angle beta, which is angle ABC. Please follow the order of my naming. When I say ABC, hope you know the order of naming. ABC. Sorry, ACB, not ABC. It's called ACB. That is the right angle. That's angle beta, ACB. Or you can say BCA, provided the point C is at the middle of your order of naming. So we see that angle ACB, which is beta, is equals to angle CBE. Angle CBE, right? What is the reason for this statement? Because you always give the reason for your statement within parentheses. So what is the reason for this our statement? The reason is that the angles are alternate, right? They are alternate, and not just that. The reason why they are equal is that the line AC is parallel to the line DE by construction. All right? Okay. So we've done that already. Now that means that angle CBE is also equals to beta, because angle ACB is beta in the diagram. Can you see that? So we now have that at hand. Now also, if you look carefully, you discover that angle CAB, can you see CAB? Because the line AD is now standing as a transversal to the line AC and BE. It's not transversing the line AC and BE. Can you see that? So you see that the angle CAB, which is alpha, is corresponding to the angle EBD. All right, and since the lines forming them are parallel, they are therefore equal. So we can come here and make the statement of equality. We can say angle CAB, also angle CAB is equals to angle EBD, right? What is the reason for this statement? The angles are corresponding, and not just that, the line of formation AC is parallel to line BE. That is the reason for the equality. Otherwise, they will just be mere corresponding angles. All right. So we've done this already. That means that it follows that angle EBD is also alpha, because angle CAB is alpha from the diagram. Can you see that? Our page is exhausted. So let me take one page for the work. All right. Please excuse me. Excuse me, I'm in a crucial meeting. Please, I'll call you later. Please, sorry for that distraction. Now, we have this already. So what we shall do now, observe carefully that angle CBA, which is lambda, and angle CBD are adjacent angles on the straight line AD. Do you observe that? Angle CBA is lambda, and angle CBD, they are adjacent angle. That is lambda and phi. You know the entire angle here is phi. All right. So we can say also angle CBA plus angle CBA plus angle CBD is equal to 180 degrees. What is the reason for this? Sum of adjacent angles on the straight line AD. All right. So we've done that before in passing videos in the first series. Now angle CBA is equals to lambda. Is it lambda? Let's check from the diagram. CBA, yes, it's lambda. So we can put lambda in this place. Then plus angle CBD is phi. All right, it's phi. But this angle CBD is broken into two parts. What are the parts? Angle CBD can be written as angle CBE plus angle EBD. All right, CBE combined with EBD will give us CBD. Can you observe that? Look at it. Take your time to look at it and verify it. So because of that, I can, in the place of CBD, I can write the sum of the parts. I can say angle, this CBD you see here can be written as angle CBE, CBE, all right, plus angle, what follows again? CBE plus angle EBD, EBD. Can you see that? And that is also 180 degrees. Now, angle CBE has been obtained above here. Look at it here. Can you see that? As beta. So in its place, I will put plus beta, then plus, while EBD is has been obtained to be alpha equals to 180 degrees. So you can see that this sum we have at hand currently, let me rewrite it in the proper way. Alpha plus, therefore, alpha plus beta plus lambda is equals to 180 degrees. Now you can see that this sum you see here is exactly is the sum of the interior angles in the triangle. Don't forget, in the triangle, the interior angles are alpha, beta, and lambda. And this line of reasoning has established that the sum of the interior angles is indeed 180 degrees. That is two right angles. Because of that, we can write QED. QED means quod erat demonstrandum. That is, this reasoning process has established the claim. All right, so we've done that already. So we are done with the proof of this particular theorem. So this theorem will be verified to be correct, and henceforth it can be used to solve problem without any fear. All right, so we want to go to the next theorem, which is about a stereo angle. I've already explained a stereo angle already. So this is theorem 2 now. So for that, I will do typing. Let me type now so that the work will be neat. All right. Okay. All right. I'm coming. Let me get this done. Okay. So this is theorem 2 now. Theorem 2, right? Theorem 2. So it's about a stereo angle. Let me put it in brackets. A stereo angle. It's about exterior angle. Exterior angle, right? This is correct. So that is the title of the theorem. So what is the theorem all about? Say the stereo. This theorem will be presented in the ordinary form. All right, the exterior angle of a triangle opposite interior angle, right? So that is the theorem. So let's do a proof of this theorem we've stated. Now to prove this theorem, we shall follow. This is a theorem. We shall follow the tradition of carrying out the proof to theorems in geometry. All right. So the first step is a statement of the theorem, which has been given to us in words already. So the second step is a diagram of what is to be proved. A diagram of the figure that is under discussion. Now, what figure? Once again, the figure is a triangle, but this time around, they give us a detailed information about the triangle. What is the detailed information? Is that the triangle is having an exterior angle. So in the implication form, this theorem will present itself as if triangle ABC has an exterior angle, then the exterior angle is equal to the sum of opposite interior angle. That is how it will look like in the implication form. If the theorem is to be presented in implication form, it will look like that. But we are using this ordinary form in this case, all right? So the next step is a diagram of what is to be proved. Let's have a diagram. This time around we're having a triangle, but in addition to the triangle, we're having an exterior angle of the triangle. So I will draw my diagram as follows. In this manner. Let me use this. So this is a triangle this time around. Then I have this. So this is it. So let me label. No, sorry, I will have to add something to it because we are giving exterior. Can you remember? So that means I have to produce a side to have into the exterior of the triangle to have the exterior angle. So I'll produce this. Yeah, this is correct now. This is the complete information. So make sure you read the statement very well to know what is given to you. You don't leave anything behind. You must know what is given to you in its completion. So let me call this A, B, C. Then we'll call this point D. All right. Why this won't become the exterior? I will label it as lambda. Now the opposite interior angles are this and this, not this one here, not this, because this one is an adjacent angle to this. So the opposite interior refer to this angle here and this angle here. So let me call them X and Y. All right. So we are done with the diagram of the figure that is being discussed in the theorem. So the next step in the tradition is what is given. Now what is given? Let's given. I'll write this in with my hand. I don't want to type again. Given. Okay. Let me use black. Or rather, let me use. Okay. So okay. Let's use black. Given. We are given triangle ABC. We can say any triangle ABC because it refers to any case. Any triangle ABC with angle CAD as exterior angle. All right, that is the addition. So compare what is given here in the first theorem. You see that are different. In the first theorem we looked at is just any triangle ABC, and that is all. That's what is given to us. But in this case now, we are giving any triangle ABC with angle CAD, which is CAD, as a exterior angle. Right? Now we're done with that. Now the next thing is to prove. What are we to prove? That is, what is the conclusion? What is the conclusion? What is the conclusion of this particular theorem? Well, to prove that the exterior angle, that angle CAD, which is CAD, is equal to the sum of the opposite interior angle. That is equal to angle X plus Y. All right, and the angle CAD is lambda. I want to prove that. Can you see that? Now the next step is construction. That is, if what is given to us is not sufficient, we add to it by constructing, and our construction is based on previous knowledge, what you know before in passing. All right. Now in this case, what is given to us is sufficient. It is just fortunate that what is given to us is sufficient. So what is given to us? A triangle and its exterior angle, and that is sufficient to establish this particular theorem to establish this particular theorem. Now in that case, in the line of construction, nothing will be there, to be empty. We will not fill anything. We are not constructing. So lastly is a proof, and the proof should be in the form of a reasoning argument. So in these steps, the only step that is not necessary is the construction step. When it is necessary, you add it to it, and is gotten by previous knowledge, right? So this method of carrying out proof applies to all branches of mathematics. You don't abandon the antecedent, that is what is given to you, and you just go over to reasoning. Where are you reasoning from? You use what is given to you. If it is not sufficient, you add to it by previous knowledge. And this knowledge should be factual, should be based on, that is, you should have proved that those results are correct before you use them. All right. So let's begin to reason. Now from theorem 1, we have already established. Let me call this place. We don't know yet. Let me call this place. Let me call it Z, for example. From theorem 1, we have established. Now we can say from theorem 1. You see that we are now referencing theorem 1 because it has been proved. From theorem 1, we know that Z plus X plus y is equals to 180 degrees. Why are we making this statement? Is the fact that the sum of the interior angles in a triangle ABC, right? In triangle ABC. Let me remove this from here. In triangle ABC. Can you see that? That is the reason for the statements. Always put your reason within parentheses. Then also, in the first series of this geometrical video, we have established, or it is an axiom, that the sum of adjacent angles on a straight line is 180. And in this case, the adjacent angles here are lambda and z. All right, so I can say that also lambda plus z is also 180 degrees. So you put the reason. You see why it is good to put reason within parentheses? We're having two sum that is 180. So if we don't put reason, we may be confusing them. All right, so it's good to put your reason within parentheses. So in this case, we are dealing with sum of adjacent angles on line BD. All right, that is the straight line we're dealing with. So since these sums are each 180 degrees, we can equate them. So on equating them, it means that we have x plus y plus z, or you can say z plus x plus y, any order is accepted, is equals to lambda plus z. All right, from whence z we cancel out with z on collection of like terms. This now implies that lambda is equals to x plus y. And what is lambda? Is the exterior angle, which is the angle CAD, card, angle card. In the place of lambda, we can write the notation CAD, that is the notation for the angle lambda, is equals to x plus y. Now, this has established that indeed, look at it, what we have to prove. Are you not seeing it? It has established that the exterior angle is equal to the sum of the opposite interior angle. And this completes the proof. QED, so we can put QED. So we're done with the proof of this particular theorem. So in the next, what we shall do now, we want to look at solving problem with these particular facts. All right, we'll solve some simple problem with these particular facts, and not just these particular facts. We'll take facts from series 1 of this video to solve problem. And when we do that, we'll bring this video to an end so that you can take time to digest what you have been taught. So we'll now look at problem solving. Okay. So I have some application from a material with me here. Let me get some problems from this material. All right, I've seen one. Now, this one says find the value of, okay, this number one. In the diagram, say xy and PQ intersects at O. All right, the angle TOQ equals 64 degrees. You are required to calculate M. Can you see that? Now the options here are A, 93 degrees, B, we have 96 degrees, C, we have 116 degrees, then D, we have 151 degrees. So what the figure that is being discussed is this. Excuse me, here is this, that here is this stroke. Okay, look at it here. I think I'll move this down now. So the figure they are talking about is this. We have this, then we also have this. We have this. Can you see that? Then this is also attached to it. All right, this is a complete figure, and it's labeled as here's x, here's y, p, we have here as q, here's t, then this is 3 arrow, here's arrow, here's 64, then here's m. This point of intersection is O, as stated in the statement, as in the statements. So we are required to find m. All right. Now do we get m? Now the page is exhausted once again. Let me add more page to the work. All right. Now to get m, observe that angle POX. Can you see that? Angle POS. Please follow the order of my naming so you can identify the angle. Angle POX. That is 3 arrow. And angle POY, they are adjacent angles, and they're on the straight line XY. So by the axiom in the first series of the video I taught, the sum of adjacent angles on the straight line is 180 degrees. So I can say solution. Let me call this solution. Let's solve the problem. I can say angle POX plus angle POY is equals to 180 degrees. What is the reason for this statement? Sum of adjacent angles on line XY. All right, that is the reason behind the statement. So with this, now angle POX is 3 arrow as spotted in the diagram, and POY is m. That means this is equal to 180 degrees. Now this is a single equation with 2 unknowns. It cannot be solved unless we can get a second equation involving 2 unknowns like this. Now because of that reason, we can call this equation star. We leave it for the moment. Let's try and find one of them. Let's see whether we can get arrow or m independently. Rather arrow, because we want to find m. So let's see whether we can get arrow. Now, if you observe carefully, you see that angle POX, angle XOOT, and angle TOQ are adjacent angles, and they are on the straight line PQ. Have you seen that? POX is 3 arrow, XOT is arrow, and TOQ is 64. So they are adjacent angles on the straight line PQ. So because of that reason, the sum is 180 degrees. So I can still come and write that. Also angle POX plus angle XOT plus angle TOQ equals 180 degrees. The same reason, that is sum of adjacent angles on line PQ this time around. The line is PQ, all right? Now POX is 3 arrow plus arrow plus 64, and that is equals to 180 degrees. Can you see that? Then this will give us 4 arrow plus 64 equals 180 degrees. From whence we have 4 arrow equals to 180 degrees minus 64. All right. So when you subtract this, you shall have this 7 1 1. This, so we have 116 as a result. Please verify that. Then on dividing by 4, we have the result will be 93. So arrow become this divided by 4, and that will give us 93 degrees. Can you see that? So we have gotten the value of arrow. We have gotten the value. Sorry, no, arrow is not 93. There is a mistake. I'll remove this, please. It's not. There's a mistake here. 4 into 11, that will give us 2. We're left with 2 remaining 3. The 4 into 36 will give us 9. So this is the answer. All right, this is the answer. So now let's go to equation star. From equation star, we have the result as, instead of 3 arrow now, we'll be putting 3 times 29, right? Plus n equals to 180 degrees. Let's look at it very well. Very correct. Now, multiplying this out, we have, this is 3 times 9 is 27, 7, put down to 687, all right? Plus m equals to 180 degrees. So on subtraction, we have 180 degrees minus 87, and that will give us 93. That was the result I was calling before. So this is the answer. We'll finish solving this particular problem by use of the axioms we've considered. Note, in this problem, we did not use the fact that sum of interior angles in a triangle is 180. We can also use the exterior angle theorem because there is no triangle in this figure. There is no triangle, so no need to use the triangular fact or triangular property. Now, the second example deals with, we shall use the triangular property to solve the second example. Look at the second example, example 2. Example 2, right? Now we shall, here you see in the diagram, below, line segment PQ is parallel to line segment ST. They say find the value of X. All right. So let us draw the figure they are referring to. This time around, I will use a different color. Let me use this color. So we have a line this way, then we have another line coming in this manner. All right. Then we have this given to us. Let me use this. Connecting it to these points. Okay. So this is the major thing that is giving us. So here's Q, R is T, S, and P. Now I'll give you that this side is parallel to this side. Can you see that? And the angle here is 110 degrees. This place is X, we don't know. And here is 54. So we are required to find the value of X in this particular problem. Now, how do we find the value of X? If you observe carefully, we don't have triangle here also, but if we make proper construction, triangle will come into the problem. All right, so let us make construction. So what we do a redraw of the diagram of the figure. A redraw of the figure. Let's do a redraw of the figure. I will take this down again. Okay, so we shall do a redraw of the problem. So I will put this. Excuse me. We have this. All right. Then we have this again. Not just that, we have this. Then lastly, we have this. All right, you see that. So this is a redraw. Now, in this case, we shall extend. We shall make possible extensions. Now, if you observe carefully, in the problem, we are given that this line is parallel to this. Let me remove this first. Is parallel to this, right? And we label as follows. Here is 110 degrees. Here is X. Then here is 64. From the original diagram, from the original problem. 54 years, all right? P, Q, R, S, T. So we have here as P, yes, Q, yes, R, yes, S, then yes, T, right? So what we shall do, we shall construct in various manner. Now, observe carefully that the line QR ought to be a transversal of the lines P, Q, and ST. But it was truncated at the points arrow. That is, it was cut short at the points arrow. It was not continued. If it were to be continued, it will serve as a transversal between line PQ and ST. All these terms are explained in the first series of the video. Please do yourself the favor to watch that video because it will help you to create your foundation, right? So please, if you are gaining any value from this video, do me the favor to like, share, comments, and follow the page for more exclusive video. All right. In YouTube, please you subscribe so that you can get notified when interesting, fascinating videos are produced. So what we do, we extend this side as follows. We extend it in this manner. to meet with this. Can you see that? We extend in this manner. Now, if we do that, we now have a triangle. Can you see the triangle? We have a triangle at hand. So from here, we can reason. Now, angle S we have to find is now serving as an exterior angle. Observe, please look at it carefully. Let me remove this from here and rewrite it in this order. Okay. Now, angle, if I call this place alpha, angle S ought to be 64 plus alpha, but we don't know the value of alpha. So we strive to find the value of alpha. All right. So for that to be, let us make this extension. Let's do this. Let's draw this in this way and call this point, let's call it A. You see that? You can also draw this one also to correspond with what you've done. It's not out of place. So you can see now that line AB is parallel to line SA. All right. Since line PQ is parallel to line ST, also it follows that line AB is parallel to line SA. Can you see that? And if that is the case, this angle you see 110 degrees is equal to the angle here. All right. Can you see that? So from here we can say that angle 110 degrees. You can say 110 degrees is equal to angle. What is the angle there now? Angle QCA. All right. What is the reason for the equality? They are alternate angles, and not just that, the line PQ is parallel to the line ST. You can equally say the line PB is parallel to line SA. Anyone is accepted, all right? Because they are each parallel to each other. They are parallel to each other rather. That means this angle is now, therefore, we can say that angle QTA is equal to 110 degrees. All right. Now to get alpha, it's easy to get alpha now. This angle QTA and alpha are adjacent angles on a straight line SA. So for that reason, we can say 110 degrees plus alpha is equal to 180 degrees. From whence we get our alpha value to be 180 degrees minus 110 degrees. And that will give us 70 degrees. All right. So the value of alpha is now 70. That means, please would not put reason here. The reason for this statement, I mean this particular statement, the reason for this is the sum of adjacent angles on the straight line SA. All right. Always put your reason within parentheses. It's a good practice. So I'm taking more page again so I can complete the work. The one was done. Then to get the value of X now as required, now X is an exterior angle to the triangle because the side ST arrow was produced to Q. That makes S an exterior angle. So we can say S, but X is equal to 64 plus alpha. What is the reason? This exterior angle is equal to sum of opposites interior angles. That is the reason. We have already proved that already to be true. So that means that S is equal to 64 plus alpha, and the value of alpha is 70 degrees. And that will give us, when this is added, we have 4, then 13, 134 degrees. So this is the answer. So we're done with solving this problem. So please take your time to go through the video, go through it once, twice, and thrice for a proper grasp of it. We've come to the end of this particular video. Don't forget, I offer an online math tutoring service. If you're in need of my service, very free to get across to me. In such a service, you have the liberty to ask me questions in real life, and I will also relate with you in a way that you will get a proper understanding. All right. So thank you very much for paying attention, for being with me, for supporting me. I do really appreciate you all.